All right, hello, my friends. Welcome back. So yeah, earlier we met with NumPy, and guess what? Now we're going to get to know it a little bit better. We're going to examine the most important advantage of using NumPy, being more practical in numerical operations and behaving a whole lot more efficiently. Okay, so let's just get started without talking anymore. So my friends, we're going to be using a Jupyter Notebook. You can also follow along using Jupyter Lab. But first, I do want to start with an expression that we'll use in our primary transactions before moving on to more of the meatier stuff. So what's that? Well, I want to show you the range function. So we're going to be using the range function when we want to use numbers in a particular range in Python. For example, let's say that we want to operate with numbers between 0 and 5. We can use the range function. And you see the syntax takes a starting value followed by the value stop. And we can specify the last number of steps, namely step. All right, so let me just show you what I'm talking about. For example, we want to work with numbers up to 5. So I'll say range, and I'll first write 0. Okay, so I'll set that to be the start, and then I'll just write in 5. So you see there's a point here. The expression we wrote is not included in the ending value. You see that? So the value starts at 0 and goes up to 5, but 5 won't be included. So it's just like when we're doing indexing and slicing in Python. All right, ready to continue? No, that's not a question. It's like, no, we're going on here. Okay, so if we want, we can specify the number of steps just by putting in a comma. But since we want to output one by one, I'm going to leave it like this. But I'll show you what happens when you run the code. All right, so you see what comes up? It's close. So this expression has numbers in it now, and we can use our list function to open it. So I'll just say list and write the same expression here and run that. Okay, so here's the output that we were looking for, right? Numbers from 0 to 4 came up. Now, my friends, since we wanted to see these values, we just write them down in the list function and we get the output on the screen. However, if we were to operate with these values somewhere, we can write it in its raw form without actually opening it directly. So Python will understand what's inside even if it's turned off, so to speak. So let's just ask these numbers to progress by 2s. All right, so I'll see here, copy the entire statement below, and I'm setting the step parameter to be 2. All right, so let's run that. All right, so we get that output just like I predicted. So if this is your first time seeing the range function, now you know. So let's move forward. So my friends, we're going to create a couple of different lists here. For example, let the first one be list 1, and I'll say equals, and take values consisting of numbers like this. I'll say 1, 3, 5, 7, and 9. All right, that's enough for now. I'll create my second list. So let it be list 2, and it'll consist of the even numbers. So I'll say 2, 4, 6, 8, and 10. Now, my question to you is, what do you think we ought to do if we want to multiply the elements of these two lists with each other? Well, do you think that we could multiply it together directly? Well, let's try it out. So I'll say list 1 multiply list 2 and run it. Okay, so we get an error. It's called a type error. Now, what's it really saying? Well, basically it says that 2 lists cannot be multiplied. So it even says that 2 lists, not integer types, cannot be multiplied. So my list is not an integer, but the numbers in it are integers. What's going on? So Python's saying the type of values in the list is none of my business. I don't actually care about the type of the list itself. But if you're going to push me, it's going to cost you. Well, I guess Python's got a pretty good sense of humor. Or does it? let's not upset Python. How do we actually figure this one out? Well, let's look at it this way. We'll define a new list. For example, let's name it new list. Now let's call it a new list and let this be equal to an empty list. And we'll find it in a minute. Yeah, so now let's reach the elements of our two lists through their indexes and multiply them with each other. So how do we do that? We could start by using a for loop, yeah? With a for loop, we can navigate through the indexes of our list elements sequentially. So yeah, I say for and write my variable where my values will come in order. So I'll say I. And now I want to bring in a list with index numbers to be able to navigate over the indices of my two lists. So yeah, how can I do this? Right, with a range function that we learned just a bit ago. So I'll say range and continue. So now I'll say 0 because I want it to start from the very first index of my two lists. And now we can put in an ending value. Actually, what index is the last value of our list? So we'll count, right? 0, 1, 2, 3, and 4, yeah? So now I'll just write 5 directly into the range to include that value of 4. So that means it's going to return the number starting with 0 right through 5. However, actually, in order not to count this way every time, if I enter the general number of elements of my lists into the range function as the ending value, I will still reach the same result. See, that way I don't have to do any index number counting on my fingers. You didn't see me use my, never mind, let's go. Okay, so you do understand what we're working with here, right? What was our function in determining the number of elements on a list? Isn't it a len function? So see, I'll be deleting those 5s. I'll write len instead and write one of my two lists in it. All right, so already the number of elements is equal. I'll write a list 1. And look, what's going to happen from this len? Isn't it the number of elements of the list number 1? So the value of 5 will go directly because it has 5 components. So it was the same process all over again. However, we didn't have to count until the last index, right? So moving on with that, now my value starting from 0 and going up to 5 will become my variable I, 0, 1, 2, 3, and 4, right? So now we will use these values to determine the index number in the body. So I'm going down to the body. And let's set a new variable. I'll say x equals. Now I can multiply both list elements by getting the indices of my two lists. So I'll say list 1, open square brackets. Look, I'm going to index. And what comes up here? The I value, right? So in other words, my value I will start from 0 and come up as 1, 2, 3, and 4 respectively when the loop starts. And so I'll have reached the elements of the list 1 in order. Okay, so then I'll go ahead and say the cross sign plus and apply the same process to list number 2. So here I say list 2 square brackets and I place a I inside. And look at that. I'll go to the indices in both lists, multiply them with each other, and assign them to my variable x. All right, so everything's good up until here. Now I want to add it to my new list variable that I defined at the beginning each time with my x variable. So I can do this with the append method. And I'll say new list and apply the append method. And because I want to add x to it, I'll place an x. All right, so you see how we've created our loop. Now let's check with print. So I'll say print and write the name of my variable as a new list. So now let's run the code. All right, so you see, guys, the code multiplies all the elements with each other and then outputs it. multiplies 1 by 2, 3 by 4, then multiplies 5 by 6. See, so it applies the same process to each and every element. And, of course, we've now got the result that we wanted. But do you see how hard we had to work, my friends? Kinda, sorta. Yeah, we kind of had a hard time multiplying the elements of the two lists. And this is just using a first few numbers, right? So we had to think of many different algorithms and implement a few different methods and functions. So that's too hard. And this is just multiplying the two lists. Imagine how many operations we'd have to do if we had 3 or many, many more lists, or if we had to do more vector operations. See what I mean by being a costly process? You don't want to have to do any thinking, do you? Well, I'll save that for a rainy day, but let's learn how to do all these operations using the NumPy library. Okay, that's the whole point. This is where we can perform high-level mathematical functions using the power of NumPy. And that, of course, is what this whole thing is about. All right, so first up, we'll have to import the statement that's used to activate the NumPy library. Import. Yeah, it's an expression presented to us by Python, so we can use these external libraries and external modules within the program. So I'm writing import here. Now we're writing the name of the library. So we say NumPy, and then I'll say as NP. So what's the as doing here, my friends? See, Python is basically wondering, what do you want to call NumPy from now on? Well, if we say as NP, so whenever we say NP, Python will understand that we're using NumPy. So, of course, you can use some other names instead of NP, but just for clarity's sake, I really wouldn't recommend it. I mean, 99% of the time, NumPy is generally used as NP, and you want to be like the other 99, right? Let's not get into that either. Okay, so let's just run the code. Now, NumPy is active, and we can use it anywhere in the program. So, moving on. Now we're going to multiply the same two lists using NumPy. First, let's set two new variables. Let's let the first be x, and I'll say equals. Now we can create a NumPy array using our lists. So we talked about this briefly in the introduction to NumPy earlier. Well, this whole thing is kind of like an introduction, but anyway, yeah, you remember that. So we're going to examine the array creation process as a separate lesson, but right now I just want to show you how it goes. So what I do is I convert lists to arrays, and I say NP and call NumPy and put a dot. So now if you press the tab key, we can see the operations that we apply here, but since there are too many operations, I'm just writing the array directly instead of searching from the list. Okay, so the array function is used to create a NumPy array. So that's what I wrote, and the array function is a data type in NumPy. This data type we have used here is a data type just like a list tuple or a dictionary. But the difference is that we can, well, do more advanced operations with the array. So I want to place in my first list, and see, look at that. I'll just take it from above, put it below. Okay, there we've now created our first NumPy array. So let's do the same for our second list. This time I'm going to create a variable y, and I'll say equals, and again I'll say np.array. This way I'll take my second list from above and place it below. And you see my line of code is ready, and let's run it. Very cool, look at that. We now have two NumPy arrays. So let's check it. We'll check the type, and we'll see what our list has now become. So I'll say print and call the type function write my variable in it, and we'll run the code. All right, see, we have now output as a NumPy array. Yes. So now let's move on to our main operation. Are you really ready to see the power of NumPy? Fasten your belts. Look at this. See, I'm going to multiply these two arrays with each other. So I'll say x times y and run the code. And just like that, the elements in the list directly multiplied with each other. Now, you may remember that we tried pretty hard to figure this out in the very beginning. But if you notice, we just converted the lists into NumPy arrays and multiplied the two arrays to each other. Okay, so it gives us a result that we wanted very economically. So it's practical, it's low cost, and that, my friends, is the power of NumPy. Oh, but look at that. We've come to the end of our lesson. But it's not the end of NumPy. So I'll see you next time.